You know, there's a revolution happening, but it's not loud. It's actually happening on our farms and construction sites, and it is surprisingly quiet. The roar of those old diesel engines? Yeah, that's being replaced by the steady, powerful hum of electric motors. It's totally transforming the heavy machinery we rely on every single day.
Just look at this thing. I mean, it looks like something straight out of a sci-fi movie, right? But this autonomous agricultural robot is 100% real, and it's the perfect example of this huge electric shift. There's no driver, no smoky exhaust pipe, just clean, efficient, battery-powered tech that gives us a level of precision in farming that we've honestly never seen before.
So that's the big question, isn't it? What's actually humming away inside that sleek white body? How does a machine like this get the job done without a massive fuel-guzzling engine sitting in the middle of it? Well, to answer that, we've got to look at the brains behind the whole operation. The company that's actually engineering these incredibly complex systems and making this whole electric future a reality. So, on one side, you've got HANSA TMP. These guys are veterans with deep roots in traditional, powerful hydraulics. But they were smart. They saw where the industry was headed and created HYTRON, their specialized unit that is laser-focused on electrification. It's kind of like the old guard of raw power teaming up with the new school of smart technology.
And HYTRON's mission? It's crystal clear: the complete electrification of compact machinery. And that word complete is key. They're not just selling you a box of parts. They're engineering entire, fully integrated systems from the ground up.
And when I say complete, I mean the whole shebang. They design the system's architecture. They supply every single component. They develop all the custom software that makes it run, and they provide hands-on engineering support. So a manufacturer doesn't have to stress about piecing it all together. They get one single, seamless solution that's ready to go.
All right, so we know who's building it. Now let's pop the hood, so to speak, and see what electrification actually looks like. What are the essential pieces of hardware and software that make a machine like that little robot actually tick?
So basically, every electric machine is built on these 4 pillars. You've got the electric powertrains. Think of those as the muscles. You've got the battery systems. That's the heart pumping out the energy. The control units and power electronics, that's the nervous system, sending signals everywhere. And finally, the smart software. That's the brain, managing everything and making it all work together.
Okay, so you have all these building blocks in place. Now we get to what is probably the single most important decision an engineer has to make. It all boils down to one question. How do you get that stored electric power to do actual physical work in the real world?
And this really gets to the core of the challenge. Do you use electric motors to drive everything directly? Or do you use that electricity to power a more traditional, but incredibly forceful, hydraulic system? This one choice completely changes how the machine performs.
And that brings us to the 2 main paths you can take. On one hand, you have a fully electric system. That's where electric motors do everything. They drive the wheels, they power the tools, everything. On the other hand, you have an electro-hydraulic system, which is more of a hybrid approach. In that case, a big electric motor drives a hydraulic pump, which then uses fluid pressure to do all the heavy lifting.
A good way to think about it is like this. The lightning bolt, that's your pure, direct, super precise electric power. The barrel of fluid, that represents the proven, immense, raw force of hydraulics. The whole engineering puzzle is figuring out which one of these you need for the job you're trying to do.
And this is where we get to the big trade-off. The fully electric option, it gives you absolutely incredible precision and control. It's whisper quiet, and there are way fewer parts to maintain. The downside, it can really struggle with tasks that need just brute force, and trying to do that puts a massive drain on the batteries.
So think of this system as a surgeon's scalpel. It is absolutely perfect for delicate, precise work. Imagine mapping a field, monitoring individual plants one by one, or applying just a tiny targeted drop of pesticide exactly where it needs to go and absolutely nowhere else. That's what this is built for.
Now, let's look at the other path, the electro-hydraulic system. Its #1 strength, hands down, is its exceptional power density. It is tough as nails, totally robust in harsh environments, and, this is a big one, it can power all the standard hydraulic tools that farms and construction sites already have. The catch? It's noisier, it's not as precise, and yeah, it needs more maintenance with oils and hoses. So, if the fully electric system is a scalpel, this thing is a sledgehammer. It is built for pure, brute force. This is what you need for the really heavy-duty jobs, tilling hard-packed soil, lifting massive loads, or powering big hydraulic attachments like cutters and shakers.
So yeah, we've been focused on our farm robot, But this big choice between the electric scalpel and the electrohydraulic sledgehammer isn't just happening in agriculture. This technology is spreading like wildfire into pretty much every industry that uses mobile machinery.
I mean, the scope of this revolution is just huge. We're seeing it on construction sites, in the municipal vehicles that are cleaning our streets, and with the forklifts and logistics vehicles that are powering our entire supply chain. Electrification is fundamentally changing how work gets done across all these critical industries.
So, when you boil it all down, what does this big shift really mean for the future of these industries and for our environment? What's the ultimate takeaway here?
It really comes down to these three powerful benefits. The ability to do jobs with more precision than ever before. A massive reduction in noise pollution, both on job sites and in our cities. And of course, zero tailpipe emissions. It's simply a cleaner, quieter, and smarter way to build our world.
But you know, this really isn't the end of the story. It's just the beginning. As this technology gets more powerful, more efficient, and more affordable, it raises a really big question. With farms and construction sites already being totally transformed, what's the next major industry to go quiet?